Hey everyone, it's John, and today we're going to continue on the BGP video series. In today's video, what I want to discuss is BGP confederations. Now, what are confederations? Confederations are a strategy to solve the iBGP split horizon problem, much like route reflectors, in that because of iBGP split horizon, there is a requirement to fully mesh iBGP speakers within an autonomous system. That clearly presents scalability issues, and confederations provide a strategy to break that down into smaller pieces and introduce eBGP behaviour into iBGP. Now that might sound a little bit obscure and abstract, but I think this demonstration should help you conceptualise it and see what's going on. So first things first, what I want to do is just discuss a few key points which I've written on the right hand side here. Some people ask, so when you configure a confederation, does it act like eBGP or iBGP? What is it? Well, the answer is kinda both. It acts like eBGP in the way that, for example, like I've written here, confederations like eBGP require the eBGP multi-hop command if you're peering between loopbacks to increase the default time to live value of 1. So what does that actually mean? So in this topology, as you can see here, we've got one large AS, AS5, we've got an external AS, AS34, and another external AS, AS79. Now within AS5, we've broken it up into 3 confederations. These are sub-ASs, AS65501, AS65502, and AS65503. Now, the peerings between these sub-ASs, these confederations, for example, this peering here between router 2 and router 3, if you remember, with iBGP, we're often peering on loopbacks, and we're using an underlying IGP. In this case, we're going to be using OSPF within this entire AS. But to peer between these two, you actually need to use the eBGP multi-hop command because we're traversing kind of 2 different autonomous systems. They're sub-ASs, AS65501 to AS65503. Because of that, we have this eBGP-like attribute of having a time to live value of 1. So if we try to peer in the loopbacks here, it's just going to go 1 hop here and not reach it. We need to basically say, listen, to reach the loopback, we're going to use that command of eBGP multi-hop, and I'm going to specify 2 hops, which is going to get me from 1 to the router and then 1 to get into the loopback. If that's confusing, go back to my previous videos where I discussed that more in depth. So that's one point. We do have an eBGP-like behaviour within a confederation. Conversely, confederations also act like iBGP. The key thing here is that confederations, like iBGP, as I've written here, do not modify the next hop attribute. So that is classic iBGP behavior. So what does that actually mean? So let's have a look. For example, say here, router 11 is going to advertise a prefix in, let's say, of like the AS 79797979/32 loopback. He's trying to introduce that into this larger AS5. Now what happens, it injects it in here, okay, and here as well, but let's just focus on this link. It injects it in here. Now this router sees that to get to it, its next hop will be this interface here, which is going to be 205.0.0.1. This is 205.0.0.2 here. So the next hop is 205.0.0.1 to get to that loopback we've just advertised, okay, so this interface here. Now, if we were advertising with true eBGP, if this really was a different AS, this one here, AS65503, once this router here advertised it to number 3, router 9 would actually modify the next hop to this interface here, gigabit 02, and that would change so that the next hop would not be here anymore, it would be modified here. However, within iBGP, as you know, we don't modify the next hop attribute. So once this goes in here, it's injected, we're looking at gigabit 00's interface, which is 205.0.0.1. It goes in here. Now, even though we're kind of crossing different ASs, we're going from one confederation to another, it doesn't act like eBGP fully. We still have that iBGP attribute whereby we're not going to change the next hop. So the next hop is still going to be this gigabit 00, which is 205.0.0.1. So we pass it here. This router's going to see the prefix 79 79.79.79.79/32 with a next hop of 205.0.0.1. This passes it here. This router is going to see 79.79.79.79 with a next hop of 205.0.0.1. Now, obviously, the problem is that if these routers can't get to this interface, or this network rather, then we don't have the reachability. And we're actually going to see there's an issue with confederations propagating these routes when we don't have reachability, and we'll explore that later on. Now, what I want to do is also mention that route reflectors, because people often compare route reflectors with confederations, obviously. They say, what's better? Is a route reflector better? Is a confederation better? Really, it's up to you. I would say generally, if you want the real answer, generally I would say route reflectors are better. Route reflectors are much easier, there's less design issues, and they're used much more commonly. Confederations have a special use case whereby if you're trying to divide control between a very, very large AS, you want to use separate BGP policies, confederations might work for you, but the key point here is that confederations and route reflectors do not have to work against each other. It's not an either or. It's not like you use either confederations or route reflectors, and I've configured this lab to demonstrate just that. Route reflectors can also work within confederations. Now, what does that actually mean? So, if we look at this AS here, okay, this confederation rather, AS65503, we've got this confederation here. See, within a confederation, these four routers, we still have the basic iBGP in that we have to have a full mesh, okay? So that means within a confederation, 3 will have to go neighbor 9.9.9.9, remote AS 65503, neighbor 5.5.5.5, remote AS 65503, neighbor 4.4.4.4, remote AS 65503, and we're going to have to do that for every router. 4's got to pair with 3, 5 and 6, 5's got to pair with 4, 3 and 6, 6 has got to pair with 5, 4 and 3, so on and so forth. So we still need that full mesh. Same up here, 9 needs to pair with 8 and 7, 7 needs to pair with 8 and 9, 8 needs to pair with 9 and 7. So within the AS, we still have to have, within the sub AS, the confederation, we still need to have a full mesh, okay? Again, that does present scalability issues, so you can still use route reflectors within a confederation. So we can break this large AS of AS5 into 3 confederations, but within a confederation we can still use route reflectors, and that's what I'm going to do in this demonstration. I'm going to pick maybe router 5 in this one to be a route reflector. So up here we'll just have our mesh of a confederation. Up here we'll have these 3 meshing together within a confederation, and in this confederation we're going to use a route reflector so that every one just needs to pair with 5. So 5 will pair with 6, 4 and 3, but 6 only needs to pair with 5, 4 only needs to pair with 5, and 3 only needs to pair with 5, reducing it. So we can actually see that route reflectors and confederation can actually work synergistically together and to make things scale a lot better. So without further ado, that kind of long preamble, I think we should kick on and get into the actual configuration. So let's go and do that. Now what I will say is that underneath all this in AS5 we have OSPF running. We've got all these common networks advertised and have full neighbor relationships, and we also have the loopbacks of each router advertised into OSPF. In the case of router 1 we have 1.1.1.1, router 2, 2.2.2.2, 7, 7.7.7, the same format as the previous videos. Okay, so what I'm going to do first actually is grab these external ASs, AS34, AS79, and just configure those peerings first. One final point, okay, is that see from the point of view of this router here and this router here, they do not see the confederations. They're only going to see remote AS5. Okay, so when we're doing the configurations on this router here, the peering of this router here and this router here, we'll say remote AS5, not remote AS 65503. In the case of router 11, when we're peering with this router, it's going to be remote AS5, not remote AS 65502. That's not the way it works. The externals only see the large complete AS, the real AS, and within that we're going to be using private ASs within our own autonomous system, and that'll be able to see the confederations but not without. So let's go and do it then. So let's have a look. See, we have router 10, and we'll just do router BGP 34, and we'll do our neighbour, and our neighbour is going to be 105 rather. 002 and remote, and like I say, it's going to be 5. We're doing neighbor 110.002 remote 5 because the AS actually is 5. Okay, now let's go here and we'll do router BGP 79 BGO. Try that again, John. BGP 79, and we'll do neighbor 200.002 remote. Again, it's remote AS5. Neighbor 205.002 remote. Oh, type that right, John. Neighbor 205.002 remote AS5. Okay, so that's us configured just the configurations on the external peers. Now let's go to the edges and do this here. Okay, now how do we start this configuration? Do we do router BGP 5 or router BGP 65503? Remember this is key. You start with the actual confederation number. Okay, so we're doing router BGP 65503. Okay, now the way we are going to present our AS to the world is by doing our BGP confederation identifier, and we're going to specify the identifier, which is AS5. Okay, so that's the way you configure it. Router BGP, then use the sub AS, the confederation number, and then do BGP confederation identifier. Now here's the thing, okay? Router 5, as you can see, we're also going to be peering with a router within a sub AS 65501 and a router within 65502. So it's important that we let the router know that we're going to be peering with confederations, not just with general ASs. So we're going to say BGP confederation peers, and we're going to say 65501 and 65502. So when we type in remote AS 65501, the router knows, oh wait, now that's just not a normal AS, that's a confederation. When we type in remote AS 65502, same again, it knows it's a confederation and not a normal AS. Okay, so let's go and configure just the external peer just now. So we'll do neighbor 105.001 remote 34, and we should get our external peering coming up. There we go. And let's do the same on this router here, number 4. So it's the same process. We're going to do router BGP 65503 BGP confederation identifier is number 5. Now number 4, as you can see, isn't peering with any other ASs, any other confederations actually. It's not peering with any router up here or any router up here, okay? So, whilst it might be easier, whilst it might be easier to just type in AS, confederation peers 65501, AS 65502, you can do that, but it's not necessary. You only need to be doing it with the edge routers, which are actually going to be peering with the confederations. So in this case, I'm just going to leave that out. If it feels more comfortable to just add it in, then add it in. There's no big issue there. So do neighbor 110 and 001 and remote 34. We should get our peering coming up. There we go. And let's do the same over up here. Okay. Router BGP 65502 this time. BGP confederation identifier is 5. And number 8 again isn't going to be actually peering with any other confederation, so we don't need to type in that BGP confederation peer command on this one. Again, if you want to, by all means, if it keeps your head straight, just type it in, but you don't need to, so we'll just leave it. So we're going to do a neighbor 200.001 remote 79, and we should get our external peering coming up. There we go. And let's go to router 9 and do the same thing. Now router 9 is a little bit different because router 9 is also going to be peering with a router in AS 65503, so we're going to put that other Confederation peer command in. So router BGP 65502, BGP Confederation identifier 5, BGP Confederation peer is going to be 65503, and what we're going to do is peer just this one here, this external peer just now. So we'll do neighbor 205.0.0.1 remote 79, and we should get our peering coming up. Okay, that's us. So what we've done is we've configured this iBGP peering and this iBGP peering as well as here and here. Now let's focus on doing the actual iBGP Confederation peerings. This is what we're actually here for. So, like I say, within this entire AS5 we've actually got OSPF running, so we can see that we can actually ping all the loopbacks which we're going to be peering off. So for example, ping 2.2.2, ping 5.5.5, we can ping all these things. So we can peer on these loopbacks. And like I say, within a confederation, unless we're using route reflectors, we need to have a full mesh peer. So number 8 needs to peer with 9 and 7, 7 needs to peer with 9 and 8, and 8 needs to peer with 7 and 9. So let's go and do that. Right, so number 8, router BGP 65502, BGP Confederation identifier. In fact, we've configured that part, haven't we? We just need to do neighbor 7.7.7, remote 65502, neighbor 7.7.7, update source is loopback 0, neighbor 9.9.9, remote AS 65502, neighbor. Okie doke. And let's go to number 7. Router BGP 65502, BGP Confederation identifier is 5, BGP Confederation peer is 65501, 65503, and we're going to do neighbor all the 8s, remote neighbor all the 9s, and let's go to number 9 and complete that. So as you'll notice, I'm actually not doing the inter confederation peering just now, just the inter, not the intra, the inter. So I'll do neighbor 7.7.7, remote 65502, neighbor 7.7.7, update source loopback 0. Have I not configured that yet? Router BGP 65502. Neighbor 7.7.7, remote 65502, neighbor. We should have those peerings coming up. Okay, and number 8 as well. There we are. Okay, so let's go to this router here. And we'll do router BGP 65501, BGP Confederation identifier is 5, BGP Confederation peer is 65503, and we shall do neighbor all the 1s, remote 65501, because we're peering with this router here, number 1, which is in the same confederation. And we'll do neighbor all the 1s, update source loopback 0. And let's do router BGP 65501, BGP Confederation identifier is 5, BGP Confederation peer is 65502 and 65503. Neighbor is 2.2.2. Remote 65501, neighbor 2.2.2, update source loopback. Okay, so what have we configured so far? We've configured the external peer, the external peer, the external peer here, and the external peer here. We've meshed these three, but not configured the inter confederation configurations. We've only done the intra, and the same here, we've meshed these. Now this bottom one here, we're actually going to incorporate route reflection as well. So what I'm going to do is go on to router 5, which is going to be our route reflector, and configure that as well. The reason why I'm doing this is just so you can see that you can actually use them both in tandem together. So 65503 we're in, and BGP conf identifier is 5, BGP confederation peer 65501, 65502, and let's just focus on these here. So neighbor 6, neighbor 4, and neighbor 3. So we're going to do neighbor 6.6.6, remote 65503, and our update source is loopback, and we're also going to configure this as a route reflector client. And let's go to number 4, remote 65503, neighbor all the 4s, route reflector, and number 3, 65503, neighbor all the 3s, update source loopback, neighbor, and again making it a route reflector client. So now let's go and configure the rest of these to do their peering, and then after that we'll do our inter confederation peerings. So we're going to do router BGP 65503, BGP conf I, BGP conf peer 65501, neighbor 5.5.5, remote 65503, neighbor 5.5.5, update source loopback 0, and we should be peering with our route reflector. There we go. Let's do the same on number 4. And router BGP 65503, BGP conf I, BGP conf peer. In fact, number 4 isn't peer. In fact, I've configured this router before anyway, so it doesn't matter. So we'll do neighbor 5.5.5, remote 65503, neighbor 5.5.5, update sources loopback. Let's peer with that route reflector. There we go. And the last one is this here. Number 3, router. Oh. Have I configured BGP on this yet? No. Okay, so router BGP 65503, BGP conf identifier, BGP conf peer 65502, and let's do neighbor 5.5.5, remote 65503, neighbor 5.5.5, update source loopback. Okay, so what we've done here is we've configured our external peers on the edges. We've configured our mesh within this sub AS confederation, and we've peered our mesh, even though it's just 2 here. And in the bottom one, we've configured every one to peer with this route reflector here. Okay. So what we need to do now is do these inter confederation peers. So that would be this here, going from AS 65503 to AS 65501. Same again, 503 to 501. 503 to 502, and 503 to 502, and 503 to 502 as well. So let's go and do that. We'll work from left to right then. So, like I said, if we do the show run section BGP, we have told our our router that if we peer with 65501, it's a confederation peer, so it knows to treat it like a confederation. So when I type in neighbor 2.2.2 remote 65501, it's known, okay, this is a confederation we're doing. And we're going to do an update sources loopback 0. Now what I'm going to do, I'm going to miss out something, and you'll probably notice what I'm doing, but I'm doing it deliberately. And we're just going to see this just so you can get full demonstration of this. So neighbor 1.6.6 rather, remote 65503, neighbor 6.6.6, update source. Give it a second, and we'll wait, and we'll wait, and we'll wait, and you'll wait indefinitely, because what's going to happen is we're not going to get a peering up, because we're actually getting this iBGP like behavior in that the TTL value is only 1. Okay, that is because, like I say, confederations act like a blend of iBGP and eBGP, and this is an eBGP behavior. So what we need to do is do neighbor 6.6.6 eBGP multi-hop and 2. That is so we can peer with the loopback. Okay, physical interface, then 1 hop into the loopback. So let's go and do that, and let's do that on this as well. Do the mirror, and we'll do neighbor 2.2.2 eBGP multi-hop 2, and we should now get our peering pop up. There we go. Okay, so let's repeat that process for 1 and 5. So we're going to do neighbor 5.5.5 remote 65503, neighbor 5.5.5 update source loopback 0. Oh, neighbor 5.5.5 eBGP multi-hop 2. Neighbor 1.1.1 remote 65501, neighbor 1.1.1 update source loopback, neighbor 1.1.1 eBGP multi-hop 2. Should get our peering. Okay, now let's peer from 5 to 7. So neighbor 7.7.7 remote 65502 this time, neighbor 7.7.7, and we'll do update source loopback 0, neighbor 7.7.7 eBGP multi-hop 2, because we're going between confederations. And let's just do the same here. We'll do neighbor 5.5.5 remote 65503, neighbor 5.5.5 update source loopback, and neighbor 5.5.5 eBGP multi-hop 2. There we go. And we'll do neighbor 7.7.7 remote 65502, neighbor all the 7s, update source loopback, neighbor all the 7s, eBGP multi-hop 2. Neighbor all the 3s, remote 65503, neighbor all the 3s. eBGP multi-hop 2. There we go. And lastly, let's do this link here. So neighbor 9.9.9 remote 65502, neighbor 9. Oh. eBGP multi-hop 2, and we'll do neighbor, put my peering with number 3, is that? Yep, neighbor 3.3.3 remote 65503, neighbor 3.3.3 update source loopback, eBGP multi-hop 2. There we go. So that's us got our full configuration, and like I said, the purpose of that was to avoid, if this was one entire AS, we would need to peer with everything, which would be 5 would need to, sorry, 2 would need to peer with 6, 1, 5, 4, 3, 7, 9, 8. So let's go and do that. and let's go and inject a prefix in. So we'll do int loop 79 25 25 25, and let's inject that into BGP. Router BGP 79 and add that in. Okay. Oh, not neighbor. That should be network. So we do a show IPBGP, and it's now been injected. So let's look at our peers. And that's got it here, and the next hop is 205.0.0.1, as you can see, which is, or 200.0.0.1, which is here, and this one here as well. Now, so how is it going to actually work here? We're going to see let's do show IPBGP, and you'll notice that the next hop is 205.0.0.1. So how is that going to affect the advertisement into the other confederation? So let's look at this. So show IPBGP, and you can see that the next hop remains unchanged. That's what I was talking about, okay? So you see 205.0.0.1, which is up here. It's went into this router here, and this router has made it absolutely unchanged. So this router still sees the next hop is here, which is clearly, even though we're going between one confederation, one sub AS to another sub AS, we're not changing that next hop. We're still very much acting like iBGP here. And you'll notice this curious behavior here, okay? So we've got it in number 3, okay? So what about number 4? Do we have it here? Nope. What about number 5? Nope. And that is because it's not going to relay, because it's not got a path to it here. See that? Show IPBGP. We don't have a best path because it is inaccessible, that next hop. Okay, so if this was an ordinary eBGP, we would pass the prefix here, and as this one passed it to a different AS, it would modify the next hop to here. Because this is still considered as one large AS, AS5, we are not modifying that attribute, so this router is not changing that next hop. So when it goes to here, when it goes to here, and it goes to here and here, the next hop is still here, and none of these routers can see that next hop. So again, we've got two options. In the previous video, we'd taken these networks here and redistributed them into OSPF using a route map, connected subnet, and the same here. In this case, what I'm going to do is just go to these edge routers here and just type in the command next hop self. That is going to mean that when we get a prefix here and we advertise it to a neighbor and our neighbor here, we are going to change the next hop to ourself, which means it's going to be a next hop will be 9.9.9.9, and the neighbor will be this one here, will change to 8.8.8.8. And because of our iBGP, which is OSPF, we actually have reachability to all of those. We can reach 8.8.8.8 and 9.9.9.9. So let's do that. Right. So router BGP 65502, and we'll do neighbor 3.3.3. So we're passing to this router here. We're going to change the next hop to ourselves. Okay. And actually we'll do the same with we'll just do that, and I'll just quickly show you this actually, rather than spend too much time on it. And we shall do router BGP 65502 neighbor 7.7.7 next hop self. Okay, so let's see how that affects things here. This router here, now with this show IPBGP, we can suddenly see it because the next hop is reachable, which is 9.9.9, which is reachable through OSPF. Okay, so because we have that reachability, now and only now we're actually seeing that. So is it going through down here? Show IP BGP. And we're actually seeing it here. And here's the thing I want to notice, right? What are we traversing? Really, we're traversing AS 65503 and AS 65502 and AS 79 to get from 34, but from the point of view of AS 34, it doesn't see the confederations. Its AS path is 5 and 79. So this router here only sees 5 and 79. It doesn't see these inner workings of the confederation. That is only available to the actual that only works really when working with the confederations, which actually sees it in the parentheses, the brackets. It sees it because we're running confederations within here, but from the point of view of the outside world, we're only seeing 5. Okay, so that is a basic introduction to confederations. I thought I would do it just to highlight the problem with the next hop and how that can be fixed with using next hop self, or like I say, I do prefer to redistribute the connected subnets on the edges back into the IGP, but in this case use the next hop self and do that, and also with the TTL of the iBGP multi-hop. So that's the end of the video, and I'll see you guys soon. Bye bye.